Okay, this software is called Simulink. It's a part of the MATLAB. It's a part of MATLAB, and uh, what I've done is I've made a very small control system here. Can you see that? So here we have a transfer function, a process that we are trying to control. There's a gain block, and right now I have put a gain of 1, and I'm giving a step input. Excuse me. So I'm giving a step input to this system. And as I give the step input, I want to look at the output that the process gives me. So let me run this. So as I run this and I open the scope, you can see that the output is basically this signal. So you can see that this is a step input. So the input is going to become 1 at this point, and the output becomes 1 after a certain time. There is an exponential rise, and the output becomes 1, but it takes a little bit of time to do that. Now, here's what I want to do. I want to make this system faster. I want this curve to reach 1 faster. And what do I do? Uh, So the is a change in gain going to help? I don't want to change the process, because the process, let's say, is a motor. Okay, I don't want to change my motor. I don't want to change my process, because that's a given for me, and replacing it would cost me so much more. It would be very expensive. So what can I do to make this system faster? So the only parameter that I have in here to play with is the gain. So let me change the gain. I'm going to make it 10 times. And now I'm going to run my simulation again, and I'm going to take a look at my scope. And you can see that the signal has not changed at all. It's exactly the same. You had the same kind of a curve is coming here, even though the gain has increased, which means the final value of the signal has gone to 10, but the speed of the signal has not changed, right? So in an open loop system like this, there is no way in which you can make this motor faster, make this process faster. Okay. So what I'm going to do then is build a closed loop control system, as I've shown to you on the screen here. Okay. And so this is exactly the same loop as here. The only thing I've done is I've added a feedback, and I'm going to connect this to the scope. And let's compare these two outputs. So let me run the simulation, and let's open the scope. So if you open the scope, the blue trace is the output of the open loop system, and the yellow trace is the output of the closed loop system. And you can see that the gain is very different, right? Even though, I'm sorry about this. Uh, Let me just try to get this and minimize it a bit. We don't need it that big. Okay. Even though the gain in both cases, so here it is 10, here it is 10, but in the closed loop system, you can see that the gain is much lower than the open loop system. Okay. So one of the disadvantages of a closed loop system is that you get a much lower gain in a closed loop system. But let's try to see what are the advantages of a closed loop system. And to do that, what I'm going to do is I'm going to, because this time profile is exactly the same, it doesn't change even if I change the gain. I'm going to change the gain of the open loop system, so that this final value instead of 10 comes to around 1, so that we can see both the signals together. Okay, so I'm going to change this gain here to 1, and I'm going to run the simulation again. Let's open the scope, and you can see what's happening here. So this is the response to the open loop system, which is slow and we were not able to change it, but just adding a feedback loop has increased the speed of the system by so much, right? So your system has become much faster than it was before because of the feedback loop. So in one sense, what you could say is then the transient response of the system. And what do I mean by the transient response? The time it, the response in between. So, okay, uh, the output is going to become equal to the input after some time, right? In an open loop system or in a closed loop system, uh, and uh, but between the time when the output has become equal to the input till that happens, so uh, the output becomes equal to the input somewhere here, but in this intermediate time there is a change in the signal, so that's called the transient response, the changing response. Transient means changing. So the transient response becomes much faster in the closed loop system than in the open loop system. So one of the advantages of a closed loop system is that you can get a more tighter control of the transient response. Now let's take a look by change what happens if I change this gain here. Okay, so let me just disconnect this scope and just let's look at the closed loop system and let's try out what happens for different values of gain. So there you go. Okay, so that's the signal, and you are getting approximately, let's say, a full 100% rise approximately in 3 seconds. Is that okay? So the response starts here, rising, and by 4 seconds, it's almost reached its final value. So 3 seconds rise time to approximately 100%. Now let's increase the gain here. Let's make it 5. Um, if you make it 5 and I run this simulation again, and let's look at the scope. Now how much time is it taking? Can you see as I increase the gain here, now it's almost reaching the final value in 1 second instead of 3 seconds. If I increase the gain further, you can see that the transient response becomes faster and faster. And you can see here that this is getting to almost 100% in like 1 second. So it's become faster. Now, in an open loop system, we had already seen that this gain did not make any difference to the transient response. So so that's the difference between an open loop system and a closed loop system when it comes to transient response. Of course, the the cost of that transient response is a lower gain in a closed loop system. You can see that even though I have put a gain of 10 here, the overall gain is not even 1. Actually, it's less than 1 because the input is a unit step. So the input is at 1, but what you're getting is much less than that. However, in an open loop system, if I had a gain of 10, I would get a gain of 10, but it would be much slower. So that's the kind of, what should I say, a compromise that you have to make between the two.